All right, let's jump right in. If you're a developer or work in DevOps, you have absolutely been here before. You're looking at your dashboard, everything's green, the infrastructure looks totally fine, but you're still getting that one dreaded message from your users.
Yep, that's the one. The app is slow. So you do your checks, right? You look at your Kubernetes cluster, all the pods are healthy. CPU usage? It's normal. Memory? Looks perfectly fine. And still, the user is having a bad time. Clearly, the infrastructure metrics aren't telling you the whole story.
And so, the guessing game begins. Where is this lag actually coming from? Is it something in the API code itself? Is our database getting hammered? Maybe it's a slow response from Redis or, that third-party API we depend on. Heck, it could even be the network. The point is, without the right tool, you're just stabbing in the dark, and that's a frustrating place to be.
This really gets to the heart of it. See, normal monitoring gives you that big picture, outside-in view. Something like CPU is at 70%, which is useful, sure, but it's not specific. Application Performance Monitoring, or APM, gives you the inside story. It tells you why a request is slow. It's the difference between knowing the fever is high and knowing which infection is causing it.
And this is exactly where a tool like Datadog APM comes into play. Let's just define it real simple. It's a tool that lets you see inside your application, not just the server it's running on. Think of it like this. Regular monitoring lets you see the building from the outside, but APM gives you the full architectural blueprints.
Right. And this is the perfect way to visualize that idea. Standard monitoring is the outside view. It tells you if the house has power. APM is the inside view. It tells you that the toaster in the kitchen is the exact thing that's tripping the circuit breaker. It gives you that critical context and precision. So you're probably wondering, how does it actually do this? Well, Datadog works by installing the super lightweight agent right inside your application's container. And this agent, it just watches everything. So when a user makes a request, the agent follows it on its entire journey, from the moment it hits your load balancer, through all your different services, over to the database, and all the way back to the user. And that whole recorded journey, it's got a name. It's called a trace. You can just think of it as a complete end-to-end video recording of one single request flowing through your entire system.
So how do we get all that juicy detail from a trace? Well, it's because a trace is actually made up of smaller pieces. Each individual step along the way, like an API call or a specific function or a database query, is called a span. So if the trace is the whole story, the spans are the individual sentences that make up that story.
And this is where the magic really happens. When you look at the spans inside a slow trace, the problem just jumps right out at you. You can see here, okay, API processing was fast, 20 milliseconds. The auth service call, 50 milliseconds, no problem. But then, bam, look at that. A database query that took 900 milliseconds. There's your bottleneck. No more guessing. The data points right to the answer.
Okay, so let's pull this out of theory and put it into a real-world situation, something anyone running apps on a platform like EKS will definitely recognize. We're moving from just guessing to getting a straight answer.
So, picture this. Your checkout API is lagging. Instead of SSHing into a bunch of boxes and digging through logs, you just open up Datadog. You navigate to your checkout service, you filter for the slowest traces, and right there, plain as day, you see it. One specific Postgres query is consistently taking 3 seconds to run. The problem's found in minutes, not hours.
And this is so crucial. The problem had nothing to do with your Kubernetes setup. It wasn't a CPU issue. And trying to fix it by scaling up and adding more pods wouldn't have done a thing. The root cause was just a single, inefficient database query hiding deep inside your application code, and APM found it instantly.
So that really brings us to the main takeaway here. If you remember one thing, let it be this. Datadog APM is all about tracing every single request, so you can find the exact service, the exact function, or the exact database call that's causing the slowdown. It turns debugging from a dark art into a straightforward science.
And that really just leaves us with one last question to think about. You've seen how this works, you've seen the kind of clarity it can bring, so the only question left is, what about your application? Where are the hidden bottlenecks slowing things down for your users right now, just waiting to be found?